Thank you. And there's an echo coming. Thank you, sir. You can proceed.
All right, thank you. So we shall go straight to our lesson. So today's lesson, as I've stated earlier, we shall look at okay, those are my particulars there. For those who have just joined today, Mr. Katete has already mentioned my name there. That is Mfula Mordecai of Chinsali Special Unit in Muchinga Province.
Just a moment, sir.
Okay.
You can close. Then now you open the one you have because viewers can see the screen. So stop sharing the screen and yes.
Okay.
Then start. You get what you're supposed to
share.
You can, yes, you can share.
Okay, so at the end of the lesson, I expect that you'll be able to demonstrate the exchange of oxygen and carbon dioxide in the lungs. Then you look at the mechanism that makes it possible for gas exchange in the lungs. So these are the two main areas where I need you to focus on for today's lesson. So in the first place, we've mentioned already to say the exchange of oxygen and carbon dioxide takes place in the lungs. This is a respiratory organ where the exchange of oxygen and carbon dioxide takes place. Now, I'd love to find out from you, the learners there, since it is there in the respiratory system where we have the lungs, which organ exactly do the two processes? Because we've identified that it's the lungs, but inside the lungs we have the specific organs which works on this. Anyone with an idea? You can put up your hands, then I'll point at you. We have the lungs, but it's specific. I want to be so specific because the lung is the big organ, but we have where exactly the gaseous exchange takes place for these two gases. Where exactly? Anyone to attempt? An attempt.
Are you? Yes, the teacher. The voice is making a big echo. I don't know where you are you in the room or what is nearby?
I've locked myself in the car. I don't know what is happening.
Can you switch off for any device which is in the car? There's echo coming. Switch off any device. If there's a carrot.
There's nothing.
Open the windows.
I'm always here. Even last time.
Open the doors.
This is my class.
Open the doors.
Okay. I don't know.
Open the doors of the car.
In fact, I'm just outside now.
Fine.
Yeah, is the echo gone?
Yeah.
All right. Thank you.
There's a building near.
No,
there's
just
the same thing, but outside the house. You saw the car other side, you are in between. So the go on to the other end so that the car is on its own.
Okay.
You are between the building and the car.
So still the echo is still coming.
A bit.
The echo is still
voice, coming. A vehicle it's coming, but not as it was.
Okay.
The voice is bumping from the car to the house and back. So where there's on one. Okay. Thank you, sir.
All right. We can proceed. So I was asking a question to say where exactly do we have These we've said the lungs are the main organs where oxygen and carbon dioxide exchange. Now, maybe inside the lungs, maybe name one organ or organs, maybe so to say, which helps this process of exchange of gases. Anyone to attempt? In fact, I want to remind everyone that I sent an assignment, NotesMaster, but I've seen I think no one has attempted. I'll go on. I'll show you maybe the organ that maybe you failed to identify. So that's the organ there. What's the name? How do we pronounce that name? Maybe if I may find out.
Alveolus.
Put up your hand. That is Lorraine.
You put your hand, or else you might be penalized.
Okay, Lorraine, thank you so much. That's the structure of an alveolus. Now, alveolus, that is single. Then when we have millions of them, they are called alveoli. Alveolis. This is single. When we say alveolus, it's single. Alveoli, that is plural, a lot of them. So if you look at that one,
Excess teacher.
okay.
Let's get into the car. The wind is stepping. Is stepping. Okay.
Yeah, thank you. The echo is still coming.
Okay.
It could be network sometime. It's network, but I've been using the same place for the past
Okay, go ahead.
lessons. Okay. So this is the structure of an alveolus where the exchange of gases occur. These two gases, we are able to see that the one coming in, that is oxygen. There are millions in the lungs. There are millions of them in the lungs. So they perform the exchange of gases, that is oxygen and carbon dioxide. So we have oxygen coming in, and what we are seeing in blue, that is carbon dioxide leaving the alveoli. So oxygen is carried in the blood through these blood cells, the red blood cells. So there you can see, if you've observed on the structure there, you see we have the capillaries. That is where blood is coming from, coming into the alveolus. Then it is leaving there. So those arrows, they are showing us how. Lorraine, you can mute yourself. Lorraine Mlenga, you can mute yourself. So there, when breathing in and out is, you are breathing in and out, there carbon dioxide is coming out and the oxygen is getting inside. So there's gaseous exchange which takes place there in the alveolus. So those that part which is where they're showing air, that is an area where air comes in and it has provided a large surface for exchange. The surface there is large and it helps oxygen and carbon dioxide to exchange in a good way. So I'll further go on to demonstrate how this happens. So inside the alveolus, there are in main alveoli that we have in the lungs. This is what happens. We have the blue arrows. They are showing that carbon dioxide. You can see CO2 and O2. O2 we all understand that is oxygen. Then CO2, that is carbon dioxide. So if you observe closely, you see that O2 is coming in and CO2, which is carbon dioxide, is going out. So that is the process which occurs there in the lungs, in the lungs inside the alveolus, which are in millions. So that's what happens. You can see there is the flow of the red blood cells. If you had observed closely, they are moving because air goes through the bloodstream using those capillaries. Then, as you continue breathing in and out, there's that circulation, exchange of gases, that is oxygen and carbon dioxide. So you are able to observe that, and that clearly tells you what really happens there when we are breathing in and out. So that's what happens there.
Is
Now,
it possible? Excuse me.
okay.
Is it possible you can plug your mic and plug again? And you can try.
All right. I don't know there if it's still making some echo.
Echo is still there. Okay, we can go on this. We'll work on it after the session.
Yes,
Go
I
ahead,
think
sir.
I don't know it's network. Maybe it's failing us today. Okay. So what is it that was making that process? That process was happening because of diffusion or diffusion, whichever way you pronounce it, diffusion or diffusion. So gas exchange occurs through the process of diffusion or diffusion. I don't know the pronunciation, people differ. Diffusion, diffusion. So it's what makes the exchange of these two gases, which is carbon dioxide and oxygen, to come in and out. Now, I would love to find out from you or the learners there what you understand by this term, diffusion. Anyone to give me an attempt concerning the definition for diffusion? You can put up your hand, then I'll point at you. You just give me the definition of diffusion. We have Lesubilo Kabeke, yes. Lesubilo, you can unmute yourself and give us the answer. What is diffusion?
It is the movement of air from high concentration to low concentration.
Okay, thank you. Ngosa Chilemia. Ngosa.
It is the movement of atoms or molecules from where they are in higher concentration to where they are in lower concentration.
Okay, thank you. Thank you, Chambemba. Chambemba is gone. Mutula, your hand is up.
It is the movement of atoms from a region of lower concentration to a region of higher concentration.
Okay, to the region of lower concentration. Okay. Okay, to a region from the lower to high. Okay. Okay. Any other attempts?
Matthew's
Matthew's
mobile, you can be the last one.
You can unmute yourself, Matthews. Okay, maybe we move on.
Proceed.
Yeah,
Yes, we move.
Your answers were
We
very
can only
good.
pick 2, 3, then we go.
Okay. So diffusion is the process by which particles of substance move from a region where it is present high. So you mark the word where it is high the concentration of low region, well, to the region of lower concentration. So it moves from high to low. Where there are many particles there, they move to where there's nothing. So you need to differentiate, or you need to take note of high to low. So that is very correct. Some answers were very correct. Thank you so much. Quickly, maybe you can cite any example, maybe in our day-to-day living, where you can cite an example of diffusion. Alice, there is something like galaxy. Alice.
Cigarette smoke diffuses into the air.
You can speak up.
Cigarette smoke diffuses into the air.
Okay, cigarette smokes diffuses into air. Coming from this person who is smoking, that's where it is high, coming to the region of low concentration. Okay, we're going to Matthews. An example. Matthews, you can speak up. Okay, go back to the Subiro, Kabeki. Please, Subiro.
There's a request that you can edit diffusion.
Sorry? There's a request that I...
You repeat the definition of diffusion.
Okay, I repeat on the definition of diffusion. Okay, diffusion is the process of a little bit slow. Diffusion is the process by which particles of a substance move from a region where it is present in high concentration to a region where it is in low concentration. It's the process by which particles of a substance move from a region where it is present in high concentration to a region where it is in low concentration. So high to low concentration. A region where it is high, for example, a mom is cooking in the kitchen and you smell that aroma. So it's coming from where there's that concentration, high concentration, coming to the low concentration. So that is diffusion. We move on. Though I've seen some hands are still up, like Matthews, you want to speak?
No, we can proceed. I think others can.
All right. So what we observed in the animation that we had seen previously, we had seen how diffusion takes place in the alveolus or alveoli, and we saw the exchange of carbon dioxide and oxygen in and out. Now there are mechanisms which makes that to be very possible for diffusion to occur. So what is it that would make this mechanism to occur possibly there? Lauren, your hand is up. Lauren Mlenga. Lauren Mlenga. What we want to find out is what is it that makes it very possible for diffusion to occur in the alveolus. There are some mechanisms which allows it to occur. So we want to find out what really happens in the alveolus for this diffusion to occur. An attempt. Lauren Mlenga, your hand is up and you've even unmuted yourself there. You can speak.
Lauren, if you leave your mic on, you leave the class soon. So you are supposed to mute. The next, you will know Okay, you can, there's
Okay,
Claudine hand, can you?
Claudine, she has muted herself. I think maybe we proceed.
Proceed, sir.
We proceed. So we want to look at the key features on what really makes this diffusion to be possible. So for diffusion to be possible, there are
Just a
about,
moment, sir.
all right.
Those who leave the mics on, I'm taking you up, there will be no any other way. Just know that. Thank you, sir.
All right. So we'll concentrate on the features there, which makes it very possible for diffusion to occur. When we talk about good ventilation there, we are saying there's proper circulation of gases in the alveoli there. So it's one of the key features which makes it very possible for this gaseous exchange, the two gases we are talking about, that is oxygen and carbon dioxide, to exchange. So the first feature there is good ventilation, the possibility of air circulation there. Then there's a good circulation of air in the alveolus. So the picture there, it depicts what I'm talking about here, the key features which makes it possible for oxygen and carbon dioxide to exchange. There's large surface area which has been provided, or which the alveolus and alveoli provides. There we have the big part where we can see there's air in and out. Now there's big surface area which makes it possible for the exchange of the same gases. Okay, sorry. So the other part, or the other key feature, is the moist surface. Moist surface allows this exchange of air easily. Then there's short diffusion of distance, then concentration gradient and movement of gases. So if we look at the picture closely there, we can see the arrows which are showing blood which is coming, which is deoxygenated blood, meaning blood which is contaminated with carbon dioxide coming in and diffusing inside there. Then the ones which are, in fact, it's showing that the one which is deoxygenated is going out. So the one which is going out there, it is carbon dioxide. Then the one which is coming in red, that is the oxygen. So the main key features which allows the exchange of gases, that is carbon dioxide and oxygen, it is these key features that we've looked at here. There's good ventilation, good circulation of air, large surface area, the moist, short diffusion distance, concentration gradient, and movement of gases. So what we want to know, or things that you need to take note, are the key features which allows the circulation of carbon dioxide and oxygen in the alveoli. I hope you take note of this, because this was the main feature when we looked at the mechanism on how it is very possible for these two gases to exchange. This, when you understand this, it will allow you to answer even questions that to ask on the possibility, or what makes the mechanisms that allows the two to exchange. So these, they allow oxygen and carbon dioxide to exchange. There are these very good features which are there. So we'll move on. So my lesson ends
Just
there.
a moment.
Sure.
Just a moment. Innocent is confused. Innocent, can you talk something? Can you explain where you are confused? Innocent? proceed, sir.
Innocent is confused. I think he has a yeah. So my lesson ends there. My main concentration was just on those two. So I hope not only Innocent is confused. Let's hope others were getting it. So I would love to find out from those who are concentrating in which respiratory organ does oxygen, exchange of oxygen and carbon dioxide takes place. Want to sum up?
Put your hands up.
Comfort Wewe.
Comfort.
Sir, in the lungs.
In the lungs, very good. Where exactly? Mutula mucho.
In the alveolus.
Alveolus. Thank you so much. Gas exchange is made possible due to a number of mechanisms. I think just mention 3. Mention 3. We have Titus.
So I was asking if you could repeat on the alveoli.
Okay. We go back to the alveolus or the alveoli. In the first place, I'll come to this statement. Discuss mechanisms which makes it possible for diffusion to occur. So for diffusion to occur, there are some mechanisms which allows or which makes it very possible for it to occur. So this is where I came now. I said gas exchange in the alveoli. What happens? What really happens there? What is it that makes it very possible to occur? What we are saying in the alveoli there is exchange of gases through diffusion. And we defined what diffusion is all about. And now we want to know what makes it possible for gas exchange to occur. So the key features there, we said there is good ventilation. When we talk about good ventilation, circulation, there's openings. The openings for the alveolus are good, where the passage of these two gases are very good. Then there's good circulation. When we talk about circulation, the movement of the gases there, it's very good because it has got good ventilation. So it allows the circulation of gases to be okay. Then it has also, the alveolus have provided large surface area where this should take place, where diffusion should take place. The surface area is large. We are talking about how possible is it that diffusion can occur. So that's our main concern there. I want to find out what mechanism is there which allows these two gases to exchange. So these are the features we are talking about here. We have good ventilation, good circulation, then large surface area which is provided there. Then inside there is moist. So it has got that moist which also allows that diffusion to occur. Then there's short diffusion distance. If you look at the distances there, those arrows, which is coming from, maybe if you check those red things there, those are red blood cells. Then we have now these, the outer part of the alveoli. So where there's diffusion coming from the large surface area here, where there's this empty space, and going to where we have the capillaries and the red blood cells, the distance there is very short. So the movement is easy. Then concentration gradient, the way the steepness or the way it has been made, it makes it very possible for exchange of these two gases. Then there's movement of gases which is there is very easy. So we are talking about these key features which helps diffusion to occur in the alveoli. So I think maybe there I'll still pause because it's a little bit complex here to understand. You need to concentrate.
There is still coming to say they are confused. So now let me just, can I explain the way I've understood? I think
sure. You can come in. You can come in.
What I have I want you to pay attention. There are things you need to understand. Let me draw. This part you are seeing, it is inside the lung, if not mistaken. So let me just draw this as a lung. It's part of the line of cutting. So in the last lessons, you were learning about respiratory system, where the oxygen was going inside and going to the organ called the lung. So this is just part of the lung. Let me admit people inside. So I'll be slow the way I've understood. And this is just a part. So the last part, when the oxygen enters into the lung, where that change of oxygen to get into blood, that part is what is, you said alveoli side, isn't it?
Yes,
Is it
alveoli is
alveoli?
one. Alveoli is one. Then many, they are called alveolis. I mean,
So these things are many.
Yes, this is
So
just
now,
one.
So now what happens is this red one, this one, air moves in. This should be oxygen, isn't it?
Yes,
The one, so this oxygen, it moves. Now, he was talking of diffusion for it. Then there's this part is where blood passes through. It's where blood passes through. It just goes throughout until to the heart, until the other parts of the body. Then this, what you are seeing, is the symbol of blood. So what happens is that this oxygen comes from a place where it is too many. I don't know what you call high concentration or low concentration. So
high
in short, you
concentration.
understand the high to low. So here, there's a process takes place here. You call it diffusion, sir. You call it diffusion, isn't it?
Yes.
So this comes here. When it comes, it feeds the parts of the blood that carries oxygen so that it goes to all parts of the body. Then when you are running, you are eating right now, you are eating, and there's some process going on. So what happens is that when you are doing hard work, the carbon dioxide in the body has to move. It will penetrate, it will go through the same this part with the lung. I may not be a scientist. Then when it goes here, it comes here from the blood. When the blood is exhausted, it moves out the carbon dioxide, is the one which goes right until to your nose. So I think this is what I've got. So the other one comes in when you breathe in and you breathe out carbon dioxide. I think that's a simple science I have learned of.
Thank you, Mr. Katete. Let me just maybe remind them to say this air which is coming in the alveoli there, it is coming from the windpipe, the trachea.
Can you stop the screen?
Okay.
Sharing the screen a bit. Stop sharing the screen. Okay, you can share again. You can share. Jess Mlenga, you are making, so we are removing you out of the class. You can
making me go in the bedroom.
Okay. So I want to repeat on this one. You should remember that the air there, it is coming from the trachea. And we say the trachea there, the bronchi, it's the windpipe. So the air will come here, which is oxygen. Then what happens when it reaches there? Air has to go into the blood capillaries. Which air goes into the blood capillaries? It's oxygen. Then this one, which is the one in red, is oxygen coming in. You are breathing in, and oxygen is coming to those alveoli or alveoli. So what happens there? As you do your manual work and, like, you don't need carbon dioxide. And where does carbon dioxide which way is it going to use to come out of your body? You do your exercise, you do whatever you do, carbon dioxide is not needed in the body, it has to come out. So the alveoli, it is made in such a way that it will allow carbon dioxide to go out and oxygen to come in. So what makes them, what makes it possible for the two to go in and out? There must be a mechanism which will allow the two to exchange, because one is not needed and the other one is needed. So this mechanism, which is there in the alveoli, is what we are talking about now. What makes this diffusion to be possible is these features now, which is the good ventilation. It is made in such a way that it has got very good ventilation. There's a way it allows the air to come out of the blood, which is containing deoxygenated blood, or the blood which is, the oxygen which has been used up. Because when oxygen is used up, you know the end products there, oxygen plus oxygen, then the end products there should be carbon dioxide. So after that, it has to come out because the body does not need this. So where does it come out through? It has to pass through the alveoli. It is released there. Then it goes out. Then oxygen comes in through the same pipes. Those two pipes, the pipe we have, that is the trachea there come, then branches off into the lungs. So inside the lungs there, air should come, and for it to move, because air should be moved by within the blood, and in the blood we have got red blood cells and the hemoglobin there. So that is the one now which will allow these features there, this large surface that we have, then there's moist there, and the distances which are there, they will allow these two gases to exchange. So the air which is not needed is allowed to pass or to go out using the same route. Again, the air that you need, which is oxygen, it passes through the same route. So it's the same route where oxygen comes in and goes out. Now, how is it possible that you use one route to take in what you need and what you don't need? So these are the mechanisms which allows that to occur. Let me pause a bit there. Maybe I'm a little bit fast. I don't know if they are still confused. Are we there?
Yes, one hand.
Mutula.
Muchuba.
Maybe he's not aware that the hand is up. Mutula.
Sir, are the alveoli many all the sides of the lungs, or they're just on one side?
No. Alveoli, there are millions, in fact. For this process to occur, there have to be millions of them. So this is just an extracted one, has been extracted so that you're able to see properly. But I said earlier that there are millions of them. So one has been extracted for you to see what really happens there. But this happens in a lot of them inside the lungs. Are you okay there?
Yes, sir, because I heard that a large surface where diffusion can take place. When I heard that a large surface, I thought they were big, so that they were just one side.
No. Yeah, the way they have been made, it's just unfortunate that my presentation didn't involve a lot of these drawings. You would have seen there are thousands there, but they're in a shape of a ball. They're in a shape of a ball, but there are many. Because you do a lot of activities and the body has to respire that carbon dioxide in a short period of time. Now, if you can have only one, it may take long for you to breathe out the carbon dioxide which is not needed. So there are many to help out work the process easily. Are you okay, Mfula, there?
Thank you, sir.
Most welcome.
What is the
Zelipa, you are very quiet.
between high concentration? There is a question. The difference between high and low concentration.
High and
What's
low
the
concentration.
difference between high and low concentration?
Okay, the difference between the two. Okay, Mfula, you still want to speak, or you are the one who has asked the question?
No, it's someone else. You can
I wanted to contribute.
Okay, you can contribute before I can come in.
Yes, sir. For example, in the placenta, for a fetus to get the food or to get the oxygen, there happens that the maternal blood has more oxygen than that of the fetal blood. So the fetal blood has low oxygen. The oxygen will go into the fetal blood using the villi which are on the top of the placenta, which helps the food to go into the fetal blood.
Okay, thank you so much for that contribution. Of course, the question there, the one who has asked wants to find out between high and low, low concentration and high concentration. Mwanga, your hand is up.
We can pick how many now? Just two.
Yes.
We move on. Okay, move on. It's your turn.
Sir, does the capillary have a specific name?
The capillaries have got specific names, yes. When we talk about capillaries, we've got the veins, the arteries, which brings blood in there. So here, we've just shown that these are capillaries which brings blood in. Blood low in oxygen, blood low in oxygen, and high in carbon dioxide. So the capillary there which brings, it may have a specific name, but in this case, I will simply call it a capillary because it could be a vein which brings in there. Because they are very small, tiny capillaries. Because a capillary branches off from these veins. We answered the last one because I've not answered where somebody wanted to find out on the low and the. Let me just sum up on that one, maybe. Where one wanted to find out where there's the difference between high and low. When we talk about the difference between high and low, we have, for example, where maybe where they are cooking from, you get the smell. There where it is the source, that's where it is high. Now, as it moves to another area, there is nothing. How do you get that something there is smelling nice, there is good aroma? Because there's a point. That point where it is coming from, that is high. Now, where it is spreading to, there's nothing. So there's low concentration there. So usually, those cannot be kept at one place because there's circulation of air there. So it will move from that source to the area where there's nothing. So what happens here, blood will have to use this space where there's nothing coming from where it is high. Because where it is high, it should come where there's nothing there. Hello? So I don't know.
We can pick the last question. We proceed. Titus, please. I think time is not on our side.
Sir, it's okay. It was me who was asking the difference between low concentration and high concentration.
Okay, that is Titus.
Okay.
Yes.
The feedback is said that they are able to understand now. That's the feedback. Okay.
All right, thank you.
Wind up.
Okay, I would advise learners to use different books because with integrated science, even biology is diverse, and the explanation as you get from different books, you may understand it. I know for now you still have some questions here and there, but you really need to check in different books, and NotesMaster notes have been provided there. It will still help you. I know this is complex, even other learners have been having challenges, but I can assure you, if you can take your time from the start, you will understand this, and it's very easy. And usually it comes during exams. They will bring it like that, especially the question where they say, what mechanisms makes it possible for diffusion to occur? You need to understand these features. Once that is done, then it will be very easy for you to answer the question during exams. I was doing my summary. I think maybe
You
you'll
can
be able to
summarize
answer.
some.
Sorry?
You can proceed.
Okay, maybe quickly we close the session. Any three ones that you've gotten from the previous mechanisms that makes it possible. Was we answer Jen?
Good ventilation.
Thank you, Emmanuel.
Good circulation.
Good circulation, very good, Mwanga. Okay, Alice,
Large,
go on, Mwanga, go on.
large surface area.
Okay, Alice, Nyendo.
Moist surface.
Okay, moist
I think
surface. Thank you so
they are-
much.
they are enough. We can proceed.
Yeah, thank you so much. So, having looked at those, the next part you look at the tissue respiration. So as you wait for the next lesson, please can you check and read on tissue respiration. Thank you so much for your attention, and we apologize for starting the lesson a little bit late. Over to you, Mr. Katete.
Okay, thank you so much. The first thing is, you need to come here, you make sure that your mics are on. If your mics are not on, you will be removed without warning, and don't complain. So once you see the host has removed you, please just know that you misbehaved. Most of you have got the tendency of keeping them on, and once they are on, we will not hesitate to take you out, and those who write on the screen will be banned. Well, thank you so much. This is now 4:07 p.m., meaning 19:24. And the session is done. And tomorrow we'll have the session where we are going to take you through the examinations. We have got still the hands up, but we're taking any questions this time around because we are broadcasting. The host is very far away from where people are. So it's late, we need to be taking on. Thank you so much. Have a pleasant evening. This is Mr. Katete, the host. On behalf of NotesMaster Zambia, we love you all. You are such a nice team. And go home and stay. Goodbye. Good night. Thank you.